I'm not a core contributor to Julia statistics, but I work a bit with it. I mostly, as you probably know, work with Julia data. But still, as an instructor at academia, I was interested in a simple question. So are we ready to tell people who teach introductory econometrics just switch to Julia and you can make a complete course on introductory econometrics with Julia? And today's talk, the objective is to share my experience, if it's doable or not, and what problems I encountered. So in general, to teach introductory econometrics, you need 3 components to make a complete course. So the first is you need some data pre- and post-processing tools like data frames.jl because you need to get the data and maybe to save the results, etc. The second, you need the tools to do the actual data modeling. And the last thing you need is some plotting functionality, because in general, especially in econometrics, my experience is that seeing your data, like being able to visualize residuals, etc., is really crucial. So when I faced myself with this question, so my immediate answer was the following. So I'm pretty sure that with data pre- and post-processing, we put really a lot of effort to just be able to answer yes, this is already pretty feature complete. There shouldn't be any significant barriers for using Julia to getting the data, pre-processing the data, etc. Especially what we will all heard in the data symposium, and we also will have a discussion of this today, with TS frames. So if you have time series data, you have a package for this, etc. For plotting, I'm pretty convinced that also we have everything we need. So the package ecosystem around plotting is, I think, very mature and super nice. And I really enjoy it. But for data modeling, I said, we really need to check. So I feel that yes, but maybe there are some obstacles that would stop people from start using Julia in those introductory econometric courses. So, I thought that in order to answer this question, it's good to take some process-oriented approach, so that it's not just my opinion, but I check it on something that is real. So I said, okay, let's pick some standard introductory econometrics textbooks and just reproduce it. So can we do everything in this book? If we can, then we say, well, we are ready. If not, then we will know what we are missing. So after thinking a bit, so I decided to pick the Introductory Econometrics, a Modern Approach by Jeffrey M. Wooldridge, because it's, at least I believe, the most standard book used in graduate courses all around the world for introductory econometrics. And I decided to focus on part 1, which is regression analysis with cross-sectional data. So this is chapters 1 to 9 in this book. What I have skipped is time series, panel data, instrumental variables, simultaneous equation models. So all the things that are in further parts of this book. The reason is that, at least my experience is at my university, one semester introductory econometrics actually covers only part 1. So of course you have time series courses, etc., but those are usually separate courses for this. Similarly, probably you don't teach instrumental variables in the introductory econometric course. So so of course those are all things that are needed in econometrics, but at least I thought we do not want to say that everything that is covered there really needs to be there to start teaching econometrics. And when I thought about those requirements, the answer was, well, given part 1 of the book, GLM.jl should cover all of it. So, of course, if it's time series or panel data, probably different packages would be needed, but I would expect that for introductory econometrics, you should be able to tell your students there is one package, just use it, and you will have it end to end. So, what I went out to test is, okay, let's try reproduce everything in this book using GLM.jl. So this is what I did this spring. So what I did, I reproduced all examples in the book, all problems in the book, and all computer problems in the book. So if you know this book, like examples is what's in the main text. So what Woolrich explains, then problems are problems that show results of estimation, but ask you questions. But I reproduced also, the tables that he gives, and computer problems, well, are the tasks to really for students to do something. And I also reproduced all of them the same way. And where possible, I cross-checked the results I got against what the book produced, and I didn't ship out anything in case it wasn't consistent. So everything I will say is that, so the first comment is, I was able to get exactly the same thing as Woolrich really presents. So this is like the first level of check. Additionally, while doing it, I create not a package, but a repository. Okay, so how now to switch to it? So I created a repository that contains everything I did. So it's not a package, it's just a repository for each chapter from 1 to 9. There is a file with codes for this chapter, let's start with chapter 1. So everything there. It's not always, as you can see, it's not always just doing a regression. Sometimes Woolrich says, okay, let's filter the data, let's compute some simple statistics. So I also reproduced all this. And here you can see that for all the problems, it's annotated which problem from which chapter is what kind of model. So here we have standard GLM formula to do some estimation and some post statistics, etc. There is one extra file, init example, and those are the things that I needed to define myself, and also the extra packages that needed to be loaded. But I will comment on it in a second. So, now let us discuss this point. So I already told you that I reproduced everything. So if someone wants to teach introductory econometrics using Woolrich with Julia, like a complete set of codes is there on GitHub, but what was missing? So first thing is that in GLM.jl, Cholesky decomposition is used for estimation. And I guess that the reason for it is that it's more efficient than QR decomposition, but at the same time it has lower numerical accuracy. And actually in 2 problems in the book, this caused the estimation to fail. So I propose in the codes the workarounds, so how to get the results still having the Cholesky decomposition, but this issue is fixed in 2.0 release, and this is thanks to XKDR actually contributions, where in GLM 2.0 you will have an option to choose which numerical method is used to estimate your models, and if you accept to have a bit slower estimation but with higher numerical precision, you can switch between 2 modes. So Still, the fast mode is the default, but you have a slower mode that is more accurate. Also, while working on this, and this is maybe something that will be useful for GLM.jl users, and I hope there are some in the room. Actually, there is one more difference. So you are probably aware that what GLM.jl automatically does, it automatically does multicollinearity detection. And if you have multicollinearity, you can opt in for dropping multicollinear variables automatically. And in general, this is nice. And here is also something that is a bit different, but I think it's good that we have both options. So if you use the default Cholesky decomposition, near multicollinearity will lead to dropping variables. So if you have two variables that are super highly correlated, but are actually not like one is scaled as the other, with Cholesky decomposition, if the relationship is really close, you will get it dropped. With the new option in 2.0 release, near multicollinearity is not treated as multicollinearity. So again, depending on what you need, either you want to drop, usually you want to drop super correlated things, but sometimes you want to keep them even for like diagnostic reasons, and this option will be added. Oh, it's already implemented and it's on master, but it's just not released because, as you can see, this is 2.0 release, so really a big big release because there are some breaking changes between the releases. So this is like maybe not the biggest problem, but this was a problematic at the core level, because this meant that some things that you could estimate easily in R, you switch to Julia and you just got a different result. Then there was another limitation that is currently in the works, and hopefully soon it should get merged. So GLM.jl does not have as complete support for weights as R. But again, this is something that is a PR in the works, and hopefully soon it will get merged. But again, in the codes I have shared, wherever weighting was required by Wooldridge, I implemented it like manually, and it works. So again, it was not a blocker that you cannot use it, but like there is one extra function that needed to be defined to get proper standard errors of estimates under different weights. And I implemented it, but again, there is a PR to GLM.jl where all kinds of weights are added. So support for analytic weights, inverse weights, etc. All the weights soon should be handled like out of the box. The third bullet is something that I think was the most, maybe not problematic, but the biggest thing. So GLM.jl does not provide robust standard errors when you have heteroscedasticity in the error. And this is something I had to implement. Similarly, I couldn't find like a reference implementation for LM test and for Wald test. And as, you know, for example, Wald test is really often needed if you have some more complex relationship between variables that you want to test hypothesis against, like if coefficient 1 plus 2 plus 3 are equal 0. So this is something that was missing, and I also implemented it. And the one thing that Wooldridge uses that is not covered again in GLM.jl was least absolute deviation estimator. So GLM.jl just provides a standard estimation, but not least absolute deviations. But this was relatively easy to add. And the last thing is studentized residuals. Again, this is something that sometimes is requested by users, and Wooldridge uses it, but again, I couldn't find it implemented. So all those things are implemented in this extra file that I have shown you and can be used. So what are the conclusions? So the first thing is that, I have tested the package and everything that is in Wooldridge I was able to get. And also there is a complete GitHub repository for anyone teaching introductory econometrics that you can just use those codes and give this course using Julia. Still, some features were missing, and I hope that we have this mini symposium so we could discuss which things should be really added to the package and which things do not need to be added. For example, I think that those robust standard errors or studentized residuals are something we should have in the package. Maybe least absolute deviation estimator is not something that is a core part of GLM framework, so this could be skipped. And again, if while it is not there, everything that is needed to run those basic econometrics things and is missing in GLM is there available on GitHub. So if you are missing it, you can use it. So this is like a short summary of the status of this. So I really want and expect to convince econometrics teachers at my university to switch to Julia. Now they have everything they need, so they don't have even to write one line of code. They can just copy paste the repository and follow the standard textbook. And again, if you have some questions, I invite you to ask. And if you have some comments or thoughts about which things should be added or how they should be added to GLM.jl, or in general, what should be the curation of the future development of GLM.jl, because I think it's like a really super important package that is workhorse for introductory econometrics. I think it would be good to have a bit of discussion around it. So thank you very much, and I hope someone will find this repository useful. Okay, so the question was why I don't use notebooks. The answer is because I don't use notebooks. So sorry, but like so in short, and I think many people in the community prefer terminal to notebooks because Julia terminal is like way better than notebooks. So I normally use terminal, and that's why I create the GL file. But of course, to convert them to notebooks, it should be pretty easy. So actually, I have not formatted it, but I think that they could be even automatically converted to notebooks using this literate package, because the format I have used, I have comments, and those comments literate will recognize them as text and just can automatically change them to notebooks.
You said that the Cholesky decomposition was failing. So why was it failing?
It was so I can give a general answer, and then I can give you a precise answer in the context of GLM.jl. So the general answer is that Cholesky is less numerically stable than QR decomposition, and this is like the short answer. So wherever you have an ill-conditioned matrix, you will get a problem with Cholesky and less problem with QR. So of course you can cook up a matrix for which also QR will have problem, but it is much rarer. And now the question is, okay, but in what cases do you actually find this problem in econometrics? Because what I have said is is like an abstract comment. But when do you encounter this problem in econometrics? And the answer is you encounter this problem in econometrics where you are adding quadratic terms to your models. Why? Because if you are adding quadratic terms, like here, sales and sales squared, because the range of squares was quite high, actually sales and sales squared were super highly correlated. And because of the numeric precision, Cholesky failed. And the simple solution is like divided by 1000, for example. So then you have a lower range of those values. And if you have a lower range of the values, the precision relative to the constant term, because of course here we don't see it, but we have a column of ones. So when I not divide it by 1000, I have like billions somewhere. And those billions relative to 1 are a completely order of magnitude different, and that's why you get problem with numerical precision. When I rescale it, then those squared values are more close to the constant term column, and Cholesky works. So, so this is like a GLM.jl related answer where you have problems. You might have problems with Cholesky decomposition if you have quadratic terms in your models, and the value and the variable that is in quadratic uses quadratic terms has a super high range. Like here it was sales, so I think it was like millions or billions, and if you square it, it's like a super high value. No, so what you have to do now is, as you can see in the code here, you just need to rescale it. But with GLM.jl 2.0, you will say that instead of using Cholesky, use QR decomposition, and then it will work, like without this workaround. The nice thing about the stats models package that underlies GLM.jl is that, as you can see, writing those formulas that I actually do not want a variable, but a variable divided by 1000 is super nice. So this is the good thing, I think, about GLM.jl, because in R you would need to put this capital I everywhere. Well, maybe not that much typing, but still, having a formula without those I annotations is cleaner. So, the fix for now is easy, but hopefully, it's merged. So it's not like if I switched from a current release to master, I could just use QR decomposition, but we hopefully will soon get a 2.0 release, and then we won't need this rescaling. Sorry. Yeah.
You made a really good point about the sort of the difficult judgment calls that over the GLM.jl, right? Where like GLM.jl is used sort of by a lot of different contexts, right? And so there's always a temptation to like, well, in this field, this is a very common thing that everybody wants to do, so of course it should be included in GLM.jl. But it's like GLM.jl is being used in like probably dozens of different domain applications, and every single domain has a different idea about what is like the thing that needs to be in the package, right? So there's a lot of tension in this sort of like deciding how to do that, and also that like maintainer bandwidth is super limited, and every time you put something into the package, then like to make any change in the package, you then have to update that other thing to be consistent with whatever other changes were made in the package. So it makes like the development and the maintenance a lot harder versus like having, and then of course there's a downside to having a million tiny packages that are like GLM for X and GLM for Y, right? So, but yeah, it's really tricky for something that's like so deep in the stack of so many different fields, right? Of what goes into this package.
Yeah. So actually, so I agree, and that's why I have commented, because the other thing I could do is like open issue for every this missing feature and just try pushing for including it. But this was exactly the thing that I thought that it's actually, maybe a wider comment. As a data frames JL maintainer, I know that the hardest decision is to say no. Someone will be disappointed, but if you don't start saying no, you, in the long run, will be in a huge trouble because you have an unmaintainable package. So this is kind of your comment, and I like fully agree and understand. And so, for example, this least absolute deviation probably should not go into GLM.jl. There are some things that I think should go, like robust standard errors and weights. Those are things that I probably think most of people would need. Where should tests go? It's not that clear because we have hypothesis test JL, but they are not aware of GLM. And those tests are like GLM specific.
You were putting that together,
Yeah, actually, yeah, this makes sense. So like if you say, okay, loads, hypothesis tests, and then you say, okay, so I can add several more tests that are in combination. Yeah, makes sense.
Did you compare the answers with something else?
Yeah, so as I have said, all the answers that are given in Wooldridge, I have checked them to be identical. So that's why this is this, because, those are, complaints or gripes, as we say it in Julia. But, the major thing is, well, it passed the field test of doing exactly the same thing as is expected. I think that Wooldridge was originally implemented in Stata. I have not checked it, but I'm pretty sure that it was Stata, so we produce the same results as Stata. But yes, this was like, because, you can have some missing feature, but the bigger problem is if you start getting results that are incorrect. So, I have done probably for sure several hundred regressions. I don't know if it was 500 or 200 or 700, but it was several hundred different problems. And I really checked that in all of them we get the same. And as you can see, some of them were kind of hard with this multicollinearity. And we had two problems. So this is something that your colleague has contributed and solved this problem. So apart from this is like, maybe I'm not the person to say that if I say it's good, but it was like really field tested against many, many data sets, and it produces consistent results with what the textbooks showed.